Now there's one big difference, this for lesson 3 on unit 6, that when we come to solve the system of equations, I'm just going to move this out of the way for a second, is the number of x's is not the same, and neither is the number of y's. So we have to try and get around that problem. So what we have to do is we have to make the x's or the y's the same. So if we look at the x's and look at the small number of x's, all we say is there a number we can multiply 2 by to give us 5 nicely? 2.5 is a decimal that will work, but we're trying to look for nice numbers. So let's look at the y's. Now I'm ignoring the signs for a minute, so 2 and 8. Is there a number I could times 2 by that would give me 8? And the answer to that is yes. If I was to times 2 by 4, that would actually give me 8y. If I have the same number, then I can use the method I used in the previous class. So let's actually take a little look here. There we go. And if we take the first equation and times it by 4, then we would have the same numbers. So what we actually do is literally just that, times it everything by 4. So, oops. I got a little problem with writing right now. And it's not going to let me write. So I would have 20x minus 8y equals 40, and then I would go ahead and solve. Now don't actually try and work these questions out because they're not going to give nice answers. What I'm looking for on here is, can we figure out what we should multiply by to actually give us a question that we can actually answer? So on this second one, I can see for the x's here, if I was to do 3 times 2, that would actually give me 6. So if I was to times the first equation by 2, that would actually work quite nicely. On this question here, I've got 2x and 6x. So actually if I was to times this by 3, 2 times 3 would give me 6. So if I was to times everything on that second equation by 3, that would actually give me a good answer. So you'd have 6x minus 27y equals 33, and then solve like you did in the lesson 2. Now for this one for the x's, that doesn't seem to work very nice. I'm ignoring the signs, so 4 and 12. 4 times 3 is 12. So if I was to times everything on that top equation by 3, then that should actually give me a true statement. So 9x plus 12y equals 15, and then go ahead and solve as before. Now on the fifth one, 1x, so 1 times 5 is 5. I could times everything by 5 here, but sometimes there's a second option as well. If we look on the y's for this one, 3y and 9y, I could also times the top equation by 3. So times it by 5 or by 3 would give me a correct answer. Generally you want to go with the smaller of those two, so I would probably go with times in the top equation by 3. You might want to try 6, 7 and 8, and I want to pause the video and then go back and take a look. So for this one, I could do 2 times 3, which would give me 6, so I could times the second equation by 3. Or I could times the top equation by 4, because if I did that, 2 times 4 gives me 8, and then I would have the same number of y's. So either first equation by 4 or second equation by 3. And it doesn't want to move anymore. Number 7, I could times the top equation by 2 to make the x's the same, or I could times the bottom equation by 6 and make the y's the same. Number 8, actually you don't need to do anything at all because you already have the same number of y's. So positive 8 and negative 8 means you could add those two equations and eliminate straight away. Or you could times the top equation by 3, make 15x for both, and then you could go ahead and subtract. So this is actually a realistic question. And we'll actually go through and solve this rather than just doing the first part this time. So for this question, the number of x's is different and the number of y's is different, so we have to make them the same. So if I look at the smallest number of x, I can see that if I times this by 3, that would give me 9. So I'm going to go ahead and do that. So 3x times 3 is 9x, 2y times 3 is 6y, 14 times 3 is 42, and we just recreate a new equation. We then just copy down the second equation again. And now we go back to what we were doing in the previous lesson. 9x and 9x, same number, so we can subtract to make 0. And you've got to be very careful on this next step here. This is one where a lot of people do make mistakes. It's positive 6y, take away negative 4y. So actually it becomes plus 4y, which gives us 10y. And then 42 take away 2 is 40. Divide both sides by 4. Divide both sides by 10, I apologise. And actually we finish up with an answer of 4. Once we've found one of the values, we have to substitute back to find the other value. And you can pick any of the equations that we've had so far, so 1, 2 or 3. I tend to go the one with the smaller numbers, so I'm probably going to use 3x plus 2y equals 14. So if y was 4, then 2y would become 8, and then we just go ahead and solve this equation. If we'd use the other equation that you can see here, 9x minus 4y, 4 times 4 is 16, we can go ahead and solve that as well. It actually doesn't matter which equation you choose to solve. Whichever one you solve, you're going to get an answer of x equals 2 and y equals 4. And we could always check that on a different equation to see if this actually works. So 9 times 2 is 18, 4 times 4 is 16, subtract, and we definitely do get 2 as our answer. Now, there was another way you could do this question as well, which is actually a little bit simpler. We could have made the y's the same as well. So if we make the y's the same, so I'm going to move this over here, oops. Then if I times this equation by 2, then I would end up with 4y and negative 4y. So if we times everything by 2 here, 3x times 2, 2y times 2, 14 times 2 gives me 28. And then write the second equation down again. This time, as I've got one positive and one negative, I'm going to add my two equations together, and that will eliminate them. So 6 plus 9 is 15, 4 plus negative 4 is 0, so that's gone. 28 plus 2 is 30, solve for x and we get 2, and then substitute back. So if I use the top equation here, 6 times 2 would give me 12, plus 4y is 28. If I go ahead and solve, I end up with y equals 4. So lots of different ways of ending up with the same answer. So just because you've chosen one method over another doesn't necessarily mean that you've gone wrong, but you should certainly finish up with the same answer at the end. We'll do one more example. The x's and the y's aren't the same this time, and you should really probably try the first few questions on the worksheet before you look at this one, because there's not a nice number we can times 3 by that will give us 4. Similarly, there's not a nice number we can times 3 by that will give us 5. So we have to do something slightly different, and what we actually do is we do 2 bits of multiplication. I do 3 times 4, which gives me 12, and I do 4 times 3, which also gives me 12. So I times the top equation by this number, and I times the bottom equation by this number. Now I could also do that for the y's as well. I could times this one by 3, and this one by 5, and that would make the y's the same. So if we times all of this by 4, then we get that. And if we times all of this by 3, then we end up with this. And then this just becomes the type of question we've been working with. 12 and 12, they're the same, so I'm going to subtract here. Careful with the negative here. 20 take away negative 9 is going to give me 29. 44 take away 15 is also 29. And for this one, y would equal 1. We can substitute back. Oops. Move this out of the way a little bit. We can plug 1 back into this equation up here. So 5 times 1 would be 5. So 3x plus 5 is 11. And if we go ahead and solve this, 3x equals 6, and then x equals 2. Or we could use one of the other equations. We could go back to this equation, 4x minus 3y is 5. So 3 times 1 is 3. And whichever method you use, you still end up with x equals 2. If you're interested, you could also do it by multiplying to make the y's the same. And if you chose to do that, you'd still end up with the same answer. So I times the top equation by 3 to make 15y. I times the bottom equation by 5, also to make 15y. Positive 15 and negative 15. Them being different, I'm going to add to make 0. And you can check through those steps also just to confirm that you do end up with the same answer. Now, like our previous section, there are also a couple of special cases that you need to be aware of as well. So for this one here, the x's and the y's are not the same. We can see for the x's, if we multiply this by 2, then we'd end up with 4x. So if we multiply the whole of this top equation by 2, we get 4x plus 6y equals 24. Now, unusually for this, what we've actually done is we've made the x's and the y's the same. So when we subtract here, 4x take away 4x is 0, but 6y take away 6y is also 0. So we don't end up with anything on this hand side at all. And 24 take away 20 is 4. So we end up with 0 equals 4. Now for this, it could actually be 0 equals any number, but with the exception of 0. And when that happens, what we're going to say is no solution, because clearly 0 doesn't equal 4, 0 only equals 0, and that would be the only answer that makes sense for this. So keep an eye out for this question as well, where the x's and y's both get eliminated. And it's like the one you had before. What it actually means is these graphs are actually parallel lines. So if you were to graph them, they would actually never intersect at all. Now let's look at the other possibility. If I was to do 3x minus 2y equals 4, and negative 9x plus 6y is negative 12. If I was to times this by 3, then certainly I would end up with 9x, so that would work. Minus 6y equals 12. And this time, when I add the two equations together, then I get 0, 0. But actually, this time I also get 0. And actually, what's happened here is these are exactly the same lines. If I was to times this equation by -1, I would get exactly that equation there. So when we have 0 equals 0, what we're actually going to write is infinite solutions. And it's like that graph one. The same line, if you were to graph the same line on top of itself, then it would intersect at an infinite number of points. So keep an eye out for those two special questions.